Good afternoon, ladies and gentlemen. This is Roger W. Knight, and this is another installment, an episode of my series on arithmetic lessons. In this one, we're going to do the arithmetic style, long division style of estimating square roots of various numbers. And the method, I don't remember, was actually taught in the Federal Way School District when I went there, but my father taught me this, and then I've looked it up again to refresh my memories. This method helped me a few times in college when my calculator went bluey and I still needed to calculate a square root to answer a question on a test. Because, of course, the time your calculator is going to malfunction is the worst possible time, 10 minutes into a fluid mechanics midterm or some such thing. So, here we have our first number is 256. And what is the square root of 256? Well, a square root is the number that multiplied by itself gives you the number that you're drawing the square root from. Examples are 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. And 9 times 9 is 81. And 10 times 10 is 100. So each of these numbers, the second number are perfect squares, and the first numbers are the square roots of these perfect squares. And they're basic and fundamental to drawing square roots. You kind of have to know this series of numbers. And in fact, if you look at the multiplication table on the peaches, the diagonal down here gives you those perfect squares. So it essentially is from the fact that when you multiply the two sides of a square, you get the area of the square, and a square is basically a rectangle where the length is the same as the width, and that's why we have this term square roots and cube roots and such. A cube, of course, is the volume of a solid where the length, the width, and the depth are all equal. So how do we do this? How do we find the square root of 256? Well, you do a little stitchers along two digits in base 10, each two bases. So you have this 2 here. You know that it's greater than 1 and less than 4. So the first digit will be a 1, and you subtract 1 squared, like so, and you get 1 down here. Then you bring in the next 2 digits, which is 156. Now what do? Well, you go down here, you take the 1 times 2, and you get the 2 here, and you figure out, well, how many times would 20 go into 56? Well, it seems like 7 times, but then that's not how you do it. You have to have the digit here that's the same as the digit you're multiplying by. So you might say, well, maybe that digit is 26, and you do a test multiplication. 6 times 6 is 36. Put the 3 here. 2 times 6 is 12, plus the 3 is 15. You have 156. Well, you put this here, and you know the second digit of the square root is a 6. This comes down to 0, and of course, the square root of 0 is 0. So what you have here is 16 as the square root of 256. So that's a kind of a proof of concept. It's an easy square root to do. Let's take another question, example. We have 1,296, and we do do the divisors here into the areas. You have 12. It's greater than 9, which is 3 squared, but it's less than 16, which is 4 squared. So your first digit in the square root of 1,296 is a 3. You take 3 squared, subtract that. You have 3 here. You bring in the 96 here. And how do you determine the next digit? Well, you go down here. 3 times 2 is 6. How many times does 60-something go into 396? Does it go in 6 times? Oh, well, let's do the calculation. Multiply. 6 times 6 is 36. Carry the 3. 6 times 6 is 36, plus 3 is 9. 396. So that goes to 0, and you have the 6 here. So the square root of 1,296 is 36. Now, the way this works is that if you were to put the decimal point here and here, you still get 3.6. But if you put the decimal point here or here, you get an entirely different number. And this is also true with the other perfect square I calculated. If we were to put the decimal point here to find out the square root of 2.56, well, the answer would be 1.6. So that's one of the interesting things about estimating and drawing square roots. Now we have another example. Here, let me get it out on my trusty clipboard. We have 27,878,400. But we don't divide it up by these hatchets for the thousands, because we're doing square roots, not cube roots. And so we still divide by the hundreds. Here, 2 digits here, 2 digits here. And we see that our first candidate for the digit is 27. 5 times 5 is 25. And that's just a little less than 27. So our first digit is a 5. And we put the 25 there. We now know that the square root of 27,878,400 is somewhere between 5,000 and 6,000. So you can very quickly start estimating the square root of any number by this method. And we subtract the 25 from 27, and that's a 2 here, because 2 from 2 is 0. And we bring in the 8, 7 from the next period, 2 periods. And we put that. 5, well, let's see. 5 times 2 is 10. And 100 something goes into 287. Doesn't go in 3 times, because 100 times 3 is 300. It's greater than 287. So we figure it's 2. 102 is the divisor, so the next digit is a 2. So we now know that the square root of 27,878,400 is somewhere between 5,200 and 5,300. Well, we do the 2 times 2, that's a 4 here. 0 times 2 is 0, 1 times 2 is 2. So we subtract 204 from 287. 4 from 7 is 3. 0 from 8 is 8. And 2 from 2 is 0. And then we bring in the next 2 digits, which is an 8 and a 4. And what do we do for the number that we put down here to subtract? Well, 52 times 2, well, 2 times 2 is 4. 5 times 2 is 10. Is 104 something. No, 5, let's see, 52 times, oh, it's times 2 is 4, is 104 something. But we're looking at 8,000, so 1,000, well, goes into it about 8 times. Let's guess that maybe this digit is 8. And then we have 8 times 8. We can multiply it like this just to test it. Is 64. Carry the 6. 4 times 8 is 32, plus the 6 is 38. Carry the 3. 0 times 8 is 0, plus the 3. 3 here. And then 1 times 8 is 8 here. It's 8384. Which you subtract out, you get 0. And that means the 8 is up here. And of course, the square root of 0 is 0, so we have the 0 here. So there's the answer to this question. The square root of 27,878,400 is 5,280. So this can be useful for large numbers and small numbers. Once you get good at this method, you just have to practice. Now, you go on into geometry and trigonometry, and what you find is that very common numbers, factors involved, are the square root of 2 and the square root of 3. But these are decimal numbers, and they go on a ways. They're not perfect squares, but you have the use for the square root. So you want to calculate a digital estimation. Well, let's see. We have the periods here past the decimal in hundredths. And so we have the 2 in front of the decimal point. Well, 2 is more than 1 and less than 4, so we know the first digit of the square root of 2 is going to be a 1. We subtract the 1 there, and we have that. And we bring in the couple of zeros here, 100. And we bring that out. 1 times 2 is 2. How many times does 20-something go in the 100? Well, 20 itself goes in the 105 times, but 25 times 5 is greater than 100. So you figure, well, maybe 24 times 4 is less than 100. So we try to see if that next digit is 4. 4 times 4 is 16. Carry the 1. 2 times 4 is 8. 9. So it's just a little less than 100. So we know that the next digit in the square root of 2 is 4. So the square root of 2 is somewhere between 1.4 and 1.5. That's a nice start. And do the subtraction. 6 from 0, we carry the 1 over there, reduce that to 9, that goes down to 0. 6 from 10 is 4. 9 from 9 is 0, so we have 4 here. And then we have a couple digits here. Bring down that next 0, and we have that. Well, 2 times 14 is 28. Well, how many times does 280-something go in the 400? Well, 282 times 2 is greater than 400. That's obvious. So we have a 1 here. So we know the next digit is 1. And we have 281. We subtract from the 400. Well, 1 from 10. We borrow 1 here. We put that down to 9. We put that down to 3. Is 9. 8 from 9 is 1. 2 from 3 is 1. So we have 119. We bring in a couple of more zeros. What's the next digit? Well, 141 times 2, you get 2, 8, 2, something. What's this next digit? 282. Wonder if that's a 4. Well, we can try that. 4 times 4 is 16. 2 times 4 is 8, plus the 1 is 9. 8 times 4 is 32, so we put the 2 there. And 2 times 4 is 8, plus the 3 is 11. And we're just under that. So we know this next digit is a 4. So we already know that an estimate for most practical purposes of the square root of 2 is 1.414. And we can use these last two digits if we want to know how much more than 1.414 it is, and how much less than 1.415? Do we need to round it up to 1.415 or keep it down at 1.414? Well, we can do the subtraction, carry the 1 here, that becomes a 9, that becomes an 8. 6 from 10 is 4. 9 from 9 is 0. 2 from 8 is 6. We can a couple more. We're looking at 8, 8, 2, 8, 8, 2. So we have 28,280 something going to 64. Well, it probably goes in there 2 times. 2 times 2 is 4. 8 times 2 is 16. Carry the 1. 2 times 2 is 4, 5. 8 times 2 is 16. 2 times 2 is 4, 5, 6. And, well, it looks like 2 goes in there. And you can keep on going. So you can keep on going at it however many digits you want when you want to calculate your square root of 2. But for most practical purposes, this is going to be good enough for most practical purposes. Now, I'll show you again with the square root of 3. And again, 3 is less than 4 and greater than 1. So the square root of 3 is going to be between 1 and 2. So we know that there. We subtract the 1. We get a 2. And then for our multiplier for the next 2 digits, which we bring down, 1 time. It is 1 times 2. Well, you have the 2 here. How many times does 20-something go into 200? Well, 20 goes into 210 times, but 28 might not go in there that many times. Maybe we'll experiment with 27 times 7. 7 times 7 is 49. Carry the 4. 2 times 7, 14. 89. So it looks like that fits right there. Like so. And this digit becomes 7. So we know that the square root of 3 is somewhere between 1.7 and 1.8. And we do the subtraction. We carry the 1 there, make that a 9, make that a 1. 9 from 10 is 1. 8 from 9 is 1. We have 11. We bring in a couple more digits. We make another multiplier. 1.7 times 17 times 2. Well, 7 times 2 is 4. 1 times 2 plus the 1 is 3, so it's 340 something. How many times does that go in there? I'm guessing 3 times. So the next digit should be 1.73. 3 times 3 is 9. 4 times 3 is 12. Carry the 1. 3 times 3 is 9, plus 1 is 10, so that fits in fairly nice. And again, we carry the 1, we bring that down to 0. What do we got here? 9 from 10 is 1, 2 from 9 is 7. And we're looking at 0 from 0 and 1 from 1, so 71. We bring in another pair of digits to get the next digit. And we keep on going. Well, 3 times 2 is 6. 14, 3, 4, 6. How many times does 346 go into 7100? Probably 2 times, because that looks close. 2 times 2 is 4. 6 times 2 is 12. Carry the 1. 4 times 2 is 8. Plus 1 is 9. 3 times 2 is 6. So we got a 2 here. 1.732. Do the subtraction. Again, we do all this. 8, 6. You know, every time you have to borrow one from the next one over, you have to do that. And this happens a lot in this type of calculation. 4 from 10 is 6. 2 from 9 is 7. 9 from 0 is 1. So we have 176. We bring in a couple more digits. And what's our multiplier? 2 times 2 is 4. 3 times 2 is 6. 4, 3. Well, we're looking at 34,000 going into 17,000. So you know the next digit is 0. So for all practical purposes, a good estimate for calculations of the square root of 3 is 1.732. So that's our lesson on drawing square roots by the arithmetic method. If they are teaching it in the schools you're going to, good for your schools. If they're not teaching it, well, this video fills that hole in your education. So that's my series on arithmetic lessons. And have a nice day, and feel free to watch my other videos. And thank you for watching this video.